the law of sines, we're not dealing strictly with right triangles anymore. We're dealing with non-right triangles, but it also works for right triangles. But now we can use any triangle, and we have something that works for all of them. SOHCAHTOA and the Pythagorean theorem were only good for right triangles. Okay? So we were limited. First, though, we're going to do a little formula for the area of a triangle. The formula for the area of a triangle, not 1/2 base times the height that you're used to seeing, but one that uses trigonometry, 1/2 AB sine C. So for any triangle, you can find the area by taking 1/2, two sides, and then the angle between the two sides. That formula is painted on the wall over here above Cheesy Smile, 1/2 AB sine C. It does not have to be side A and side B. Like if it's triangle MNP, does that mean the formula doesn't work? No. It just means that the reason why you put in specific letters is it has to be two sides and the angle between the two sides. Side angle side. For those of you that remember your triangle congruences, you have to have side angle side measures to do the area of a triangle. So it doesn't matter what the letters are. I mean, we can throw in any letters we want as long as all three letters are different. It doesn't really matter. You're going to get the right answer. Okay? So looking at an example, finding the area of this triangle, all you do is simply plug the numbers in. In this case, it wouldn't be that. It would be 1/2 AC sine B. It's all the same formula. You simply plug in the two sides and the angle, and you type that out in your calculator. And it gives you the area of the triangle. 1/2 times 5 times 12, that's 30. 30 times the sine of 112 is approximately 27.8. I didn't give you units, but if I did centimeters, you would put square centimeters, say. You try one all by yourself. Okay, the correct answer, 1/2 times AB sine C. In this case, it'd be 1/2 BC sine A. Whatever, just showing you that it doesn't matter. Approximately 102. So there's the area of a triangle formula. The only way you could possibly screw that up is if I give you all of the sides and all of the angles of a triangle and say, what's the area? You have to know that you have to put in to the sides and then the angle between them, because you have angles to choose from. In these examples, I didn't give you an angle to choose from. I just gave you one angle. Okay. Now, the law of sines. You did this last year with Mr. Glass. Sine A over A equals sine B over B, sine C over C. I didn't paint 3 of them on the wall because you never use 3 at a time. You only use 2 at a time. But the law of sines, when it's presented and introduced, they show you all 3 so you know that it works for all 3 sides of a triangle. And it just means that when you take the sine of an angle, divide by the opposite side, you get the same exact number for all 3 sides of a triangle. And we use it to solve triangles. Kids love it. So here's an example. And the first thing you should do with the examples, especially when you're kind of struggling with what exactly we're doing, is draw a picture. So to draw a picture of this, you have to label your triangle correctly. And what you should know about labeling a triangle correctly is the sides are opposite the angles. So side B is on the bottom, away from angle B. And side A is on the right, far away from angle A, and side C is on the left, far away from angle C. So there's my picture. And it's my job to find the missing angles and the missing side. When you're dealing with the law of sines, the first thing you do is you find a letter where you have both the angle and the side measures. Does that exist here? Which letter? A. We have angle A and we have side A. So we are going to use that information as the start of our proportion. So you start with the letter where you know both. Okay? Then you move to a letter where you only know one. In this case, that's B. We don't know angle B. So for the top, where it says sine, we would put the sine of B. And on the bottom, we would put 17. Now we have a proportion. And so we can solve for B. Cross multiply. At this point, I am here. Sine of B equals 17 times the sine of 118 divided by 20. Type that into your calculator. I get the sine of B is approximately 0.7505. So the sine of our angle B is 0.7505. To find out the angle, we have to take the inverse sine, which would give us an angle roughly 49 degrees. So angle B is 49 degrees. So we have both A's, we have both B's. We know nothing about C. Now that we have two angles, though, we can subtract them from 180 to get the third angle. So we have angle A is 118, angle B is 49. We can subtract those two from 180 to get that angle C is approximately 13 degrees. Okay. So to find side C, we have to set up another law of sines. So it's kind of written sloppily up there, but I have a law of sines using our B information and our C information. Sine of 49 over 17 equals sine of 13 over x. Again, another cross multiplying. And what I end up with when I do that is approximately 5. So all it took to solve this problem was two law of sines and a subtracting from 180. There's my picture. And that means that C is 100 degrees. If you couldn't find C was 100 degrees from the very beginning, you didn't get very far. So now you can set up a law of sines with C and whichever one you want. I did A first, and I found that A is approximately 7. And then I would do the same exact process with C, sine of 100 over 9 equals sine of 30 over b. Just repeating what I just did. And for that one, I get approximately 4.6.